As we hop into our first lesson from Unit 6, we are going to begin looking at bisectors. Now, basic constructions were something that you did back in Math 1, and typically I review that as a part of Lesson 6.0, but we did not do that yesterday. I wanted to keep you with just proportions and triangle congruence. So real quickly, I'm just going to, at the top of the paper here, remind you about two major constructions that you did back in Math 1. One of those was a segment bisector. So here's a segment. Remember, bisect means to cut in half. So you took your segment, you put your compass here, and you swung an arc. And then you took it at that same length and put your end of your compass there, and you swung an arc, and you connected where they met. Now, obviously, I didn't use one, but you ended up making a segment perpendicular bisector where you knew that it cut it in half and it made a 90-degree angle. And then the other type of bisector that you learned about was an angle bisector. So we took our angle, and the first thing we did was take the corner of, or the vertex of our angle, and we swung an arc there. And where it hit on each side, we made dots, and then we swung an arc towards the middle and swung the same size arc out the middle, and we connected then the vertex through that point, and we had created two angles that were exactly the same size. Remember, bisect means to cut into two equal parts. So those two things can also happen in triangles. So we can have a perpendicular bisector that occurs in a triangle. So here we have triangle ABC, and we took side AB and drew in the perpendicular bisector to that. So that means the length of AD would be congruent to the length of BD, and that also means that these would be right angles since it's a perpendicular bisector. You can do that to all three sides of the triangle. You don't have to do it to just one. All those points do end up to meeting at a point of concurrency. We'll talk a little bit more about that later. Then you can also have angle bisectors. So here I took angle A and divided that in half, and we have this angle, which would be BAD, and it would be congruent to angle DAC. Remember, when you have more than one angle, you have to use three letters to name it. And so AD is the angle bisector, and it bisects angle A into those two equal and congruent parts. And again, you can do that to all three angles of the triangle, and it would also have a point of concurrency where all three angle bisectors would meet. The term bisect means to divide into two equal or congruent parts. So up here in our angle bisector, angle BAD is congruent to angle CAD, BAD, and CAD. That's just these two halves of angle A. And likewise up here, the perpendicular bisector creates two line segments that are the same measure or the same length, and they're perpendicular to each other. So in this example, AD was congruent to BD, that's this right here, and the measure of angle ADE, this side, is 90 degrees, and the measure of angle BDE is also 90 degrees. If you have enough information given on your diagram, then you can prove the triangles to be congruent to one another. And you can prove that two triangles created by a perpendicular bisector or an angle bisector are congruent if you have enough information on your drawing. So if I take a look at this drawing right here, side AB is the one that was bisected, and we know that because AD is marked as the same distance as BD, and we also see that we have a 90-degree angle. So CD would be a perpendicular bisector. Now, because we have these marked as congruent, and we know that these would each be 90-degree angles on both sides, we have two pieces of information marked right now. And then we learned back in Math 1 that there's only a couple other things that you can mark into that triangle. You can mark a reflexive property, which is a shared side. So these two triangles are congruent by side, angle, side, side, angle, side. So we could say triangle ACD, which is this one on the left. I guess I colored it in and didn't make it where you could see it. ACD, that one, is congruent to angle BCD by side, angle, side. So we're going to use those postulates we reviewed yesterday. If the triangles are congruent, then you may be able to find some piece of missing information or the value of a variable by using CP/CTC. Corresponding parts of congruent triangles are congruent. But you must prove the triangles are congruent first. That has to be your first step. So when I look at this large triangle, ZWY, this triangle is cut by a perpendicular bisector because ZX and XY are marked as congruent, and I see that 90-degree angle, which means it would also be 90 degrees over here. So that's a perpendicular bisector. I also know that WX would be congruent to itself by the reflexive property. Therefore, triangle ZWX, which would be this one that I'm coloring in now, would be congruent to triangle YWX, this one I left plain, by side